now look at this integral. The integral of cosine to the fourth sine 2x, or sine squared x. Since these are both even powers, we'll have to use the third method. So I'm going to rewrite this as the integral of 1/2 times 1 plus cosine 2x squared times 1/2 times 1 minus cosine 2x dx. So, multiplying this out gives me 1/8 times the integral of, and once we multiply this all out, we get 1 plus cosine 2x minus cosine squared 2x minus cosine cubed 2x dx. So, I'll have to rewrite some of these terms, and I'll get 1 plus cosine 2x minus 1/2 times 1 plus cosine, now 4x, minus, and I'm going to rewrite this one as cosine squared 2x cosine 2x dx. So I'm going to take some of these integrals. I have 1/8 times. This is x plus 1/2 sine 2x minus 1/2 x plus 1/4 sine 4x minus the integral of, and I'm going to rewrite this cosine squared using 1 minus sine squared 2x times cosine 2x dx. I'm now going to have to use a u substitution for this integral. I'll let u be equal to sine 2x, which means du, the derivative, would be 2 cosine 2x dx. Multiplying some of this out gives me 1/8x plus 1/16 sine 2x minus 1/16x minus 1/64 sine 4x minus 1/8 times the integral of 1 minus u, and then this will actually have to be 1/2 du, since I would need to divide this equation by 2. 1/8 minus 1/16 is 1/16 x plus 1/16 sine 2x minus 1/64 sine 4x minus, once I factor out this 1/2, I have 1/16 times u minus 1/2 u squared plus c. So finally, substituting back in, 1/16x plus 1/16 sine 2x minus 1/64 sine 4x minus 1/16 sine squared 2x plus 1/32. Sorry, that's just a sine 2x. Now I have sine squared 2x plus c. Let's try another one. This time I have an odd power on cosine and an even power on sine. So I'm going to use the rule about having an odd power with cosine, which says I should rewrite this as cosine squared x times sine to the negative 2x times cosine x dx. I'll then rewrite cosine squared with 1 minus sine squared times sine to the negative 2x cosine x dx. At this point, I'll let u be equal to sine x, which means du would be cosine x dx. So this gives me the integral of 1 minus u squared times u to the negative 2 du. So this is the integral of u to the negative 2 minus 1 du. So I'll add 1 to the exponent and then divide by that number, and the integral of 1 is just u. So substituting back in, I get negative sine to the negative 1 x minus sine x plus c. We also have these things called reduction formulas. So if I assume I have a positive integer n, then the integral of sine to the n x dx is negative sine to the n minus 1x cosine x over n plus n minus 1 over n times the integral of sine to the n minus 2x dx. So if I have a high power of sine, I can use this formula, possibly repeatingly, to find the integral of the sine. The integral of cosine nx dx is cosine to the n minus 1 sine x over n plus n minus 1 over n times the integral of cosine n minus 2x dx. A high power of tangent would give me tangent to the n minus 1x over n minus 1 minus the integral of tangent to the n minus 2x dx, provided n is not equal to 1. Finally, the integral of secant to the nth power would be secant to the n minus 2 tangent x over n minus 1 plus n minus 2 over n minus 1 times the integral of secant to the n minus 2x dx, once again where n is not equal to 1.